Welcome to Captain of Industry. My name is Corporal Hobbs, and today we are doing something a little bit different. So today I am going to be making a tutorial video that shows the thought process and design that I use when I make blueprints for this game. But this can also apply to games in this genre like Factorio, Satisfactory, Dyson Sphere. So I'm going to start here on a test world using the sandbox mode and just go over the process that I use when it comes to designing these blueprints. So starting off, I think something that will help people a lot is breaking your design up into your production side and your layout side and understanding that there is a difference between the two. So production side would be like your actual blueprint for producing your item, and then your layout design would be how you use that blueprint in conjunction with other blueprints or other designs for production, and how all of those link together to form your island or your factory, and understanding that you don't have to try and fit your layout design into your production design. You can do that for more advanced stuff where you want to plan everything together and do these really nice compact blueprints. But starting off, just if you're new to the genre or new to the game, don't worry about your layout design is my biggest piece of advice. Don't worry about your layout, just focus on getting your blueprints squared away, getting them up and running. That way you can keep progressing through the game, and when you do want to eventually start thinking on that, you'll have experience from getting your blueprints going and being able to work that into your layout, so you have kind of more of an understanding of how everything links together. Where I see that a lot for new players is the bottlenecks that you hit when you try to jump into blue science in Factorio, or when you start hitting into those higher elevator part requirements in Satisfactory. Dyson Sphere is when you start getting into the more complex logistical side of the interplanetary logistics. For Captain of Industry, it would be right around the time of getting into probably your lab equipment 3. That's when you start unlocking a lot of your advanced smelter recipes. You can start doing your thermal desalination, your exhaust scrubbing. You start getting into your maintenance 2, so dealing with another maintenance type, your more advanced power generation, and then jumping up into your conveyor belt 3s, getting all of that going, trying to get microchip production, where a lot of these recipes get a lot more complex. So I think that's a bottleneck for newer players. So I'll go over my design process when it comes to laying out a new blueprint. So what I like to start with first is looking at the codex here in Captain of Industry, but for Factorio it'd be looking at the recipe, same in Satisfactory, same in Dyson Sphere, where you take a look at the recipe. So what is the item that you are trying to make? That's kind of phase 1 of my approach. So in this case, I want to look at something super basic. We'll stick with the beginning stuff for now. So it's going to be steel. So what I'll do when it first comes to a new recipe or a new blueprint, new idea or design that I'm laying out, I'll use the codex, so you can access that with F1, or you hit this little button over here in the corner, and that will bring up the codex. So from the codex, I will select the first item I want to produce. So in this case, we're looking at steel. So I will control left click. That will copy the building and the recipe for that item. So here we can see how we produce that item, and here we can look at the consumption of that item. So in Captain of Industry, steel is used in a lot of different things. Think of it as iron plates, copper plates, from Factorio, and other similar items in those other games. but I'll start here with steel. So to make steel, I need molten steel. So the first thing I do is I'll lay out all of the buildings I need. So molten steel, I make that with a oxygen furnace, so same idea. I'll just control click that and drag it out here so I have a building ready to go. And then I'm ignoring all the other ingredients that I need to make the item. Same with any of the byproducts. I'm just ignoring that for now. I just want to look at the main item I need. So in this case, to get the oxygen furnace running, I need molten iron. To make molten iron, there's two options here. I can do a blast furnace, Mark II. I can also do the downgraded version of it as well, but in this case we're going to skip past the blast furnace Mark 1 and go right into Mark 2 because this is going to be around the time that you're going to start upgrading from your basic iron mine. Looking at the blast furnace Mark 2, there we can use iron scrap, we can use iron ore crushed and mix that with some limestone and coal. That will get us molten iron with these byproducts. We can also jump over to arc furnaces if we wanted to. So with the arc furnace and its upgraded version, so the arc furnace Mark II, the difference between the blast furnace and the arc furnace set of production would be with the blast furnace, we are using coal as our main ingredient for producing the molten iron. When you jump over to your arc furnaces, instead you start using graphite, and that will also start using power. So depending on your power and how much available power you have, that's where you might want to consider sticking with a blast furnace and avoid jumping up to arc furnaces too soon. In this case, an arc furnace Mark II producing the same 48 molten iron takes 6 megawatts of power versus a blast furnace using 15 coal. So depending on your island, that's where you would want to consider what constraints you have when it comes to the game. Same in like Factorio with the different assembler levels, how much power do you have? Same in Satisfactory, are you set up on coal power yet? Are you working towards your uranium and nuclear? Do you have power available, or are you barely sustaining yourself? So that's something to consider. In this case, we are just going to stick with a blast furnace. So we need blast furnace to make the molten iron. We'll ignore the other stuff for now. To make the molten iron, we need iron ore crushed. In this case, there's two different recipes. We could either do the large crushers or the small crushers. We are going to stick with the large crusher, and we'll talk about that. So the reason we are sticking with the large ones are, if we look at the small crushers, so the small crushers will take 32 iron ore and crush it into 32 crushed iron ore. Same with the large ones, just a higher volume, so 192 to 192. Instead of using 250 kilowatts of power, we end up using 1 megawatt of power. And instead of 2 people, we need 6 people for workers. But when you start looking at the ratios, which we're not quite there yet, basically the ratio for the crushed iron ore that you need, it works out better with the large crusher, so that's why we are going to use that. But before getting to that stage, we have all of our basic products laid out. So starting the process, we get our iron ore, which we get from mining, and then we get our limestone, which also comes from mining, and our coal, which also comes from mining. And then our iron scrap comes from recycling if you have that implemented on your island. If not, you can just ignore this recipe and go off of the base recipe here. But that gets us the starting kind of layout of what buildings we need to produce everything. And then going from there, I like to now go through and look at the byproducts. So I need to deal with exhaust, so that's going to be the first thing we'll look at. For exhaust, there is a bunch of different machines that will produce exhaust in this game. So in this case, and there's only two different ways to deal with it. So looking at the consumption side, we could either put a smokestack and vent the exhaust and generate some air pollution, or we can use exhaust scrubbing. For our situation, we are going to ignore exhaust scrubbing because that is a later technology. You may not have that unlocked yet, so we'll plan around it for future use and future-proofing our design a little bit. But for now, we'll just use a smokestack. So same idea, we just click on it, control click on it to copy that building with the recipe selected. And that handles our exhaust. Now the next item is slag. So slag is produced by a bunch of different processes. And there's only really one or two things you can do with it. You can either crush it, turn it into slag crush to use for your concrete slab production, which we can see here using a concrete mixer. That will make your concrete slabs that you need eventually for your construction parts and your rail parts. Or the other option is you just dump it in the ocean, dump it in the sea, or fill in any holes that you've been digging on your island. And then the other option, once you get to it, is using your contracts to dispose of your slag either through waste, sludge, or sour water. Sour water is usually the go-to method for slag. So you can do something like that, but that's more of an advanced topic. Basic processes, we'll just dump it. So we know we are going to dump that. The other thing we need to take into account for is our oxygen furnace. We'll have exhaust here as well that is generated, as well as oxygen. So oxygen, we can get that three different ways primarily. We can use a hydrogen reformer with super steam. Super steam is not unlocked until your lab equipment 4, so that's very end of the game, is when you are going to get that process unlocked. So we will ignore that one. The other option is using a electrolyzer. So you could take some of your water, produce oxygen and hydrogen from that. The issue with that recipe though is it costs 4 times the amount of power. So instead of taking 1.1 megawatts of power, you're going to get 4.4 megawatts per production process, and you only get 32 oxygen. And then you get hydrogen as a byproduct, and you'll have to deal with that hydrogen. The other option to get oxygen is our air separator. So the air separator, we are going to get oxygen and nitrogen. It's only going to cost us 400 kilowatts of power. We need 18 oxygen, and this gives us 36. So nice clean recipe. It's only going to run at 50% for just running one of these. The nitrogen, what we can do with that is we can vent it. It doesn't create any air pollution, or we could mix it with some hydrogen and get some ammonia. But for now, we will just vent it. Nitrogen's easy to get, so no worries in venting that. So now we have our oxygen over here on our cool caster. To make the final item that we want, steel, we just need water. So now we have all of our buildings laid out that we'll be using for this. So now I'd like to go back through. So that's kind of phase 1 is how I would describe it, where you pick your product, you figure out all the buildings that go into that recipe or that production chain, and then we go back through, and phase 2, I start laying out what all my inputs and outputs are going to be. So starting here at the back or near the crusher, the starting process, we need iron. So I will take a storage box, or in Factorio you could do a chest or a display showing you the item that you need. satisfactory. You could do like the LCD displays to show you the item. That way you know. Here in Captain of Industry, I'll just use one of the storages because it's easy to see what the item is. So that gets us iron ore. That's all we need for this building. Next thing we need is limestone and coal. Those are going to be brought in as well from our mining. So we have coal, and then we have limestone. The other thing is iron scrap. So iron scrap, we'll put that next to our iron ore. So iron scrap, coal, limestone, that covers all of the inputs here. We have an output of slag that we can't forget about. So I will flip the storage around so the input is on this side towards our build. So I can remember that I need to export this. So I will have slag there. That covers this building. We have the exhaust already handled by our smokestack. The oxygen furnace, we just need to deal with exhaust, and that's handled by our smokestack as well. Oxygen we already took care of, and then last item is water. So water, I will just put down a tank and mark down water there. And so that is all of our inputs and outputs except for our final product, which is steel. So I will just add that here on the end. And there's our inputs and outputs. So from here I can see that I have 5 inputs, 2 outputs for this build to get it running. And this is where you could apply some advanced techniques for your layout design, where you could take into consideration other blueprints that are using some of these same items and try and match your layout so a lot of these items are all together. That way you're not transporting them as far, and make your logistical side of supplying your blueprint with all the inputs and outputs a little easier. But that's more of an advanced feature here for the production design. It's as long as we have this marked and we know what we're bringing in and what is going to be leaving our blueprint. So we have our inputs and outputs. I would say that ends our kind of phase 2 of when it comes to designing the production chain for when I'm doing it. Now comes the third phase, kind of matching up the numbers and doing a little bit of basic math here to just figure out what our the number of buildings are that we are going to need. And there's a couple different approaches you could use for this. It's all going to be kind of personal preference and your experience with the game and just your experience with knowing the production chains. But don't be afraid of making perfect ratioed blueprints. You don't need to. It's more efficient if you do. But don't be afraid of just getting something that works, even if you just want to plug all of this together, run all your belts, and make it work that way. Just something to start progressing you through the game and getting you over that wall or over that hurdle. And then you can come back later and refine your blueprints. Once you've gotten past this process, you understand it, then you can come back, tweak it, and refine it from there. So third phase kind of optional, but for me what I like to do is I'll start here at the beginning blueprint. So I am making 192 iron ore crushed. Looking at that, I only need 48, so I'll take 192, divide that by 48. That means I can support 4 furnaces off of 1 crusher. So I'll put down 4 furnaces. Those 4 furnaces are going to generate 48 molten iron each. I need 48 molten iron each for an oxygen furnace, so that's a 1-to-1. So I'll do same thing. So 4 of those. The molten steel, I need 20, or outputs 24. I need 24, so same idea, just 1-to-1. So I got that covered. Now looking at the oxygen furnaces, I need 18 oxygen for each one of these. Our air separators generate 36 oxygen, so that means I need one oxygen furnace for every two, or one air separator for every 2 oxygen furnaces. So 36 oxygen, that means 18 and 18. That equals the 36 we're producing here, so that will run at a perfect 100%. So I need 2 air separators, 4 of the cool casters, oxygen furnaces, and blast furnaces. Now the exhaust, this at most will generate 36 from our blast furnace. Our oxygen furnace will also generate 36, so that's 72 exhaust per furnace setup. And we have 4 of them, so that's 288 exhaust. Our one smokestack here can handle up to 900 exhaust, so we're good with just one of these. So now that we have our buildings laid out, we've identified everything that we want to make this run. We have our pretty good ratios for getting everything to run at 100% productivity, meaning that we'll be able to produce the max amount of steel that we can do from this one build. In our case, we're going to have 4 sets of 24, so 96 steel out is what this set of 4 furnaces will produce. And now we start designing the blueprint. And the way I like to do this is I like to work from the back, or from the finished product side, to my inputs and outputs. So I will take this, and I know the smallest kind of subunit of this production is going to be our air separator into our 2 oxygen furnaces. So I will start with kind of lining this up. So I know my steel, I want these to be together. I will have a oxygen furnace here, and I want to easily get this oxygen to my oxygen furnaces. In this case, what I could do is move these together so my oxygen furnace can be supplied off of one pipe. So it cuts down on the cost a little bit. And then the molten channel for moving the molten steel to the cooled caster is right near the production of it. So I don't have to worry about moving stuff long distances. Everything is close to where it's being produced. And we're just kind of making or putting down like a layout of this blueprint of the module for our final production design. And now looking at the production, or the over here, I see I have this naturally forming kind of just one layer space between all of my buildings where I'm moving stuff in between. So I kind of want to keep that going through my furnaces. And one thing I could look at for considering that is the exhaust here. So I can flip this furnace so the exhaust is together. And then I can put some space in between. And now I can hook my exhaust together and run it this way towards my smokestack, with this exhaust coming in from my oxygen furnaces on the outside, being able to go over the top. So before we jump into plugging in all the pipes and belts and everything, let's go over the different pipes and belts. So in Captain of Industry, we have different tiers of belts or conveyors, just like in Factorio, Satisfactory. Each one has a different throughput or speed that they can transport items. In the case of the flat conveyor 3, so the highest level, we can move at most 450 items every 60 seconds. Same with the U-shaped conveyor. So a tier 3 U-shaped conveyor can move 450. And then for pipes, we get one extra level where a tier 4 pipe can move 900 items or inputs every 60 seconds. And then the final way of moving items is our molten channel. So we have a maximum throughput of 120. So we just need to kind of keep in the back of our head those maximum numbers that we can move items around with when it comes towards connecting these all together. The other thing to consider is the height requirements. Because this is a 3D game, we're not limited to building everything on the ground. So we can go vertical with our design. So we can go up to a height of 5 for the most part. There are some ways of getting things to go higher than that, but we'll consider 5 our limit. And one thing to consider looking at this is the molten channel. We cannot change the height, so molten has to stay on the ground. So your molten channel will always be at ground level. The other thing is looking at how we can move items through these lifts. So to get up to height 5, we would need this amount of ramp up to get a conveyor belt to that height, or we can use a lift to do the same thing. So in the case of a conveyor belt, it would only cost us 10 construction parts and some rubber. In the case of a lift, it would cost us 16 of the construction part 2s. So depending on your design and what belt tier you're using, it could be cheaper to use a lift if you're using these Mark III belts. If you're using like the Mark IIs or the Mark I belts, in this case, we can downgrade this and at Mark II belt for a rate of 200 for a throughput limit. It would only cost us 5 construction parts of the tier 3, which I believe is, yeah, it would double that cost. So it'd be 10 construction part 2s is the equivalent. Or you could use the lift to use 16 construction part 2s. So it's going to be a little bit more expensive. So depending on your situation and your size constraints and how compact you want to make your build. And the same for the U-shape lift. The other thing to consider is pipes. A lot easier to move vertically, so you don't need the space constraint for moving pipes vertically like you do for your conveyors. So the way I like to do my designs is I kind of start from the bottom and work my way towards the top. So I like to put all my molten channels in first because these have to be on the ground. There's nothing I can move around it. And then I plan out my belts and then finally my pipes. So taking that into consideration, let's plug all of our molten channels in starting at the back. So I'll plug this one in and this one in. So for our molten steel. Now this one, we need to take into consideration, do we have enough room to move the slag out from here? So here we have room that we could go up, just like this, up to a potential height 4. Or we could come out this way with it. But if we want to do something where we go either left or right from this build, as you can see with the pipe or the belt trying to get through, the belt is going to stick out either left or right hand side to make that curve up. If we want to use instead a U-shaped lift, we can do that. The issue that we run into then is our furnace is too close to our oxygen furnace, so the pipe or the belt has to go all the way around before we could get back to this lane here if we wanted to use this tile to move our belts. So what we could do is move our furnaces back by 1, and then now we can take our belt and run it this way, and then connect in our slag all on one belt this direction. I think what I want to try and do is make this a little more compact by moving our furnace together so we just have a 1 tile gap instead. Because our oxygen furnace has room here on each side, with the way we had this laid out, we can still pull our slag up from there and then route it a different direction. So we have that going. The next thing also, I'll start here with steel. Steel, I'm just going to run straight out the front of the build here. And I'm going to try and have all of my outputs on this direction over here and all of my inputs on this side here. So I will run steel that way. My next output is going to be slag. So considering slag, well, I'll save slag for later, and then I'll go over why. So those are the only two output belts I'm concerned with. I'm not looking at this section yet. I'll do all the inputs at once. So I'm focused more on the outputs and the stuff that's being made on hand, on site, before I start looking at the stuff and how to get everything brought in from our storages, where trucks would be bringing that stuff in. Or if you're playing Factorio, like where your storage boxes are, or where your main bus is, where your logistics bots are dropping stuff off. That's where you would take that stuff into consideration. And for captain of industry, it'd just be your storages where your trucks are going to be delivering your items or picking up your items from. So in this case, we already have oxygen together here. We don't need this level of belt. Same with this level of pipe here. Personal preference for myself, I don't like using the tier 1 pipes. They have a throughput limit of 60 versus a tier 2, which has a limit of 200. And the reason for that is just in my experience, I've had issues with machines not running correctly, especially when it comes to oil builds where pipes should have the throughput requirement, but sometimes they jam up and cause slowdowns, so your machines aren't running at 100%, especially when it comes to like short belts or short pipes, where there's only one or two pipe connectors or pipe connection. I've found in my experience just issues with that. So I like using tier 2 pipes, but personal preference. So let's connect this. And I don't like the way that came together. So we'll go this way. And I'm keeping everything kind of low to the ground as much as possible, so I have room to run stuff over the top of everything if I need to. Especially in like the later stage of the game when you have so many interconnected things and you're trying to run, a belt through a bunch of different builds to get somewhere. Just having stuff as low as possible just makes it a little bit easier. So next thing I am going to look at is the exhaust, because exhaust needs to get over here to our smokestack. And for now, I'm going to have a pipe balancer there. So the idea I'm thinking for exhaust is I will bring the exhaust up and through the middle like I did with oxygen, and then connect it in by going straight over the top into this pipe balancer. And then I'll do the same thing on this side. So I will run that straight up, connect it in, and then over to that pipe balancer. And then here in the middle, I will go like that. So I just came out one, moved it to the center. That way the other furnace, the exhaust, I can connect them together, move it all into one pipe, and then I have all of my exhaust funneled into this one pipe balancer. And then from that pipe balancer, I can connect it into my smokestack. And the reason I am doing this is to kind of help future-proof this design. By incorporating a pipe balancer, I can set a priority output, so I can try and send all of this exhaust to my exhaust scrubbing that I eventually put in for my design. But if that ever backs up or if there's ever issues there, then I have a way for the exhaust to get vented and I can keep my steel production running without this bottlenecking the system because of a backup and the exhaust scrubbing. So that is all of that connected. The last two items to deal with are water, which is an input, so I'll save that for last. So looking at slag, before we look at that, let's look at the size of our blueprint so far. So I'll use this brick surface here to kind of lay out what our widths are, or our dimensions. So at the moment, we'll leave that backside empty. At the moment, everything fits within this kind of tile set of the sub blueprint for this production module. And I want to kind of keep this as compact as I can, preferably, if I can. So there's a couple different methods that we could do for that. We could take a belt straight up like this. That would be possible. And then if I want to, I could just run this straight out over the top, and then I have my exhaust, my slag, and my steel all going out the middle here. And I think that would be the cheapest way of doing it. And just because I want it to match the other side, I could do that. So I could do something like that where I have all of the slag meeting here in the middle and then going out. The other option I could do if I wanted to, which I don't think there's a reason to do it here, but I could have the slag come out on a belt, go into a lift, and depending on the height that you need it to, then you could bring it out this way. So like that. And then you just mirror the same thing on the other side. And you have these guys linked together. And then you have your slag going out as well. And if you wanted to make this a little nicer, what you could also do is get rid of that exhaust pipe. That way your slag is at height 1. And then your exhaust you can bring out to height 2 like this. And then you would just change your priority out. So that's an option too, just because the pipes are easier to move around. So keeping the steel and the slag down at height 0 and height 1 could be a little bit easier for you. So that's an option. The other option, which I've done sometimes, is bring the slag out the same direction I have all of my inputs. In my experience, sometimes I have my slag output box with my inputs. So just having that all together in one location or one kind of stack of belts and pipes is an option. But I think to save on resources, oops. Put that back. Save on resources, what I will end up doing is just having the slag come straight out, over, and then hook together. And then do that. And then same on this side. So now, super compact, easy to see and understand what's going on. If you're looking at the build, if there's any issues with it, you can pretty easily see what's going on, what the issue might be. The last thing to do is now the water. So water, I'm thinking we just bring straight up. And then we can bring it right out to the front of our build where all of our other inputs are going to be. And then connect these two pipes together. Why? There we go. Add a connector there. Oh, it doesn't like going up and over. Okay. In that case, So because it's trying to go over the machine, it can't put any supports down here. So that was the issue there. So instead of going up and over the machine like that, which can cause some issues when you're blueprinting stuff, where your belts just disappear during the blueprint stage when you place them down or place them down. Instead, we'll run it this way, so there are supports and there's this gap, this tile gap here where we can run these items. And it looks like we don't need to be this high now. So instead, we will go to height 3 and then run our water pipe out this way towards the front. And then same thing, connect it over to here. And now our water pipe is, the input for it is coming down the middle and then splitting off to each side. And then double check our balancers. So we have a priority out to the pipe, going to our exhaust scrubbing eventually, and then a backup output to our smokestack as a last resort, and start venting that exhaust. So this creates one little separate module that we will use by doubling up and doing something like that. And we could even get a little bit closer by doing something like that. So now all of our production designs are here, or all of our furnaces are here. And we have no gap here, and then one gap, and then we'll have to see how these interconnect together if we decide to expand from there. Looking at this design though, I'm thinking instead of having it this way, actually, yeah, I do want it this way. And I will take this one that we just designed and I will flip it and rotate it. That way it's mirrored around. So all of my air separators are here in the middle. My exhaust is on the outside, and I think it just looks a little bit nicer and a little bit more compact. So now we have some space here available and space here available if we ever need it. When you're designing your own blueprints though, don't worry so much about that, about making it look nice or compact. Main idea is just getting the machines down and getting everything to work. You can go back later and update and kind of tweak your blueprints around to make your designs look a little bit nicer or more compact, depending on your needs. So for now, I think that will be perfect. And now let's get rid of this. We're done with that. Oh, I did not mean to delete that crusher. So this crusher will support all 4 of these furnaces running. And then we have our outputs here, our inputs here, and our crusher. Let me get rid of this concrete surface real quick and clean that up. Okay, so now looking at the the inputs for everything that we need. Turn on this view so we can see everything. So now comes the decision of how do we want to lay out the crusher, because everything kind of fits together here, and there's a bunch of different ways you could do this. The way I am going to do it, I think I will just do it off to the side. So in this case, I'll rotate the crusher that way, and then I will use this gap here in between the machines to run our belt through. And I like it to be mirrored, so we'll do something like that. And for this one, we have 192 items every 60 seconds, so that means I can use a tier 2 belt to keep everything running. And then I'm doing a gap of 2 here for those lifts. Otherwise, I would need a lot more room here on this front side to account for the ramps to get an item down to ground level. So in this case, we can see I would need was that 5 tiles? Yeah, 5 tiles of space instead of 2. So that's where you take into consideration the cost of something versus like the space and what it is you are trying to accomplish with this blueprint. So in my case, I'm not too worried about some of these lift costs. So I would rather have the space available. So I will do a lift there and a lift there. And then mirror those. And then same thing over here. And so now I have all of my lifts in, my main belt for my crushed iron ore. And the last thing we need to consider before we move on to the next items is for our iron ore crushed, we have another recipe using iron scrap. So instead of, we won't need the limestone for that, but instead of iron ore crushed, we use iron scrap. So what we can do is put that on the same belt. And what I mean by that is using a conveyor lift here, or a U-shaped balancer and then a conveyor lift, we can put a priority in on the scrap. And what we could even do is do something like that where we have the same space here. And then we would raise this up to the next level. So this would be height 1, height 2, and then we would have our scrap coming in on height level 3. So we'll do that right there. And now we also have our iron ore. Now iron ore is going to be a little bit different because we also have that on ground level. So we would, and we're using the ground level to feed in the iron ore crush to all of the furnaces. And we have our main row of items coming through here at this height. And I'll extend out the belts on each side so we can kind of see what's going on. And then we have our iron scrap. There we go. So we can see that all of our items are coming in on our belts from this direction. And that's the same thing I want to do for iron ore. And what we can do is have this pass underneath. Now it means that when we go to move the iron ore onto the next set of smelters, I will need to bring the iron ore belt out one to go around everything, and then I can tuck it back in and then continue on that way. And I already know I like having all of my belts for my inputs and outputs at the highest level. It just makes it easier when it comes to upgrading everything if they're all at the higher level from the get-go. The only one I will downgrade is the iron, the crushed iron ore belt. That one we don't need to be at max level. So we'll do something like that, and then our balancer here, we will take that as a priority in versus the ore coming from the ore crusher. So we can recycle our iron, and that cuts down on our iron use for the island. For other games like Factorio, it would be when you get into like advanced oil refining and you are dealing with cracking and trying to use other items before like an initial item. That way you stop backup, stuff like that from happening. It's kind of similar, similar principles that are being used here. So we have all of that done. Now, the last thing to consider here before we move on to connecting everything to storages is if we expand this out. So what I mean by that is if we have other refineries down a line like this, how are we going to pass materials on and what are our limits? So the main one we'll look at is checking all of our inputs and seeing what is going to be our first bottleneck for belt throughput or pipe throughput. And looking 15 coal per furnace. We can move items at a max of 450 for U-shape or flat. So coal is on a U-shape belt, same with limestone and iron ore crushed. And our iron ore, so we can support up to 30 furnaces with just one belt of coal. So I don't think that's going to be our bottleneck. Same with limestone, it's going to be even more. What is that? 75 furnaces off of one belt, so that shouldn't be a problem. Our water is 12 each, so 24 and 24, so 48 water. 48 water. We can support about 18 furnaces before we would need to run another pipe. So the major bottleneck is going to be either our iron ore scrap. So we can support 9 furnaces running off of one belt of iron ore scrap. But the major bottleneck is going to be our iron ore itself. So 192 iron ore is what we need per crusher. That means one belt will only supply enough iron ore to run 2 1/3 crushers. Meaning we can support probably about, what would that be? I think about 10. Yeah, 9 furnaces is what we could support off of one belt of iron ore. So that's going to be our limiting bottleneck. So to take that into consideration, what I will do is I will put in a U-shaped balancer here. And then I will do a priority out to the crusher here. And then I will preemptively run a second belt. And what I could even do is bring my balancer out one. That way I have one pipe or one belt underneath all my other belts that connect into this balancer, and then one that's in line with the belt going through. And then I would take and connect my level 2 or Mark II belt, and then still make sure I have my priority output. And then I like to do a priority input. You don't need to, but I like doing a priority input in these situations. That way it pulls everything from one belt and then the remaining stuff from the next belt down the line. So that gets us 2 belts in, 1 belt out. So let's do a second belt out. And we'll just follow that one along and then run it side by side with the first belt. So that handles all of our input belts for all of our materials. The last thing we need is just our water pipe. So water pipe will just run straight across the top. And then we will connect this in down here. Yeah, it's fine. We'll do it that way. So that gets us the water in, all of the other inputs in, and now we can look at making, or now we can work on the other side. So on this side, the building that sticks out the farthest is our air separator in this configuration, where our belts are going to have to come out at least this far before they can continue on. So what I'll do, what I like to do when it comes to outputs is do the priority inputs, just like before. So I'll do a priority input from this build. That way, as machines back up, only the ones that need to run kick on. Otherwise, if you're just using connectors, you could run into a situation where you have a furnace at the end that's only running at, saying producing like 1 or 2 steel plates, and you have furnaces at the front that are doing the same thing. Whereas using like these priority inputs, you will have a furnace stack that's running completely before it starts pulling from the next one down the line, and so on. That way, at a glance, you can see where, how much overhead of production you have. So, something I like to do. Don't need to, personal preference again. But now we can connect all of these together. Make sure I flip my belt. And then same thing with the slag. I'll do that as well. So input priority, and same thing here. And I like doing an output priority, that way it puts everything onto one belt, and then at a glance you can see if that belt is full and you need to go through and add a second belt or not, depending on how far you scale your production. And then the last item is our exhaust, which we're not going to do anything with for this portion of the video, but just so it's available, makes dealing with it later a lot easier. But we'll do that, and we'll just use connectors for these. If we're not making steel because the machine's backed up, then we're not going to make exhaust. I could argue the same thing with slag, so we could probably get rid of the slag input, but slag can cause a bottleneck. Exhaust can too, so maybe I should just do the balancers on here. Oops. Just so everything is the same. So there we go. Now we got our balancers on everything with the priority inputs and outputs. Except for on that one. Always a good idea to go back and double check. So that's all good. And now we can start looking at how these would connect together to make it this tileable, if that's something that you want to do with your design. When it comes to furnaces, I would recommend that, just so it's easier for you to expand in the future as you need more production, because you'll always need more production. But what we can do is look at the machine that sticks out the farthest, which will be this furnace here. So on this line right here, we can cut that and then bring that out. But we do run into a problem. So because we cut the belts there, we actually are we're not going to match on the other side if we do that. So let's put that back. So we'll have one gap right there. We'll add this back, and then we'll do the same thing on this side. So we will cut it right here on the line with the crusher. So we'll do that. And then let's see what this looks like. So that does connect in. Not too big of an issue. We do have one extra tile space there that we could get rid of. I think we'll leave it as is, because if we got rid of that, we could get this a little bit closer, but then we would need to add in on this side something like this. That way everything lines up together, which we could do. That works. So now this is easily tileable. And with those 2 belts of iron, that means we can run 4 furnaces. So I'll put 4 of those down. Or not yet. So let's get rid of all of this. Check this again, make sure we are good. So that's good. That's good on that side. And now we can look at putting our inputs and outputs hooked up. So the way I like to do this is going in the order of the belts for my inputs. I will put those on in order, starting from this side here, and I can actually get this pretty close. Before I do that though, let me take a copy of this and just move it off to the side. And now I can plug my belts in like that and like that. So that's iron plugged into my storage. The next 2 items are either going to be limestone or coal. I like to have the item that is needed more towards the bottom, and then the item that is less towards the top. So coal on the bottom. So we'll do coal. We'll do limestone. After that, then we have our scrap. So we'll put our scrap in at the end. And that's everything we need, and then water after that. And that will be everything we need as a input. And then we just have our output. So over here, kind of same idea except for reverse order. So we will do our slag and then our steel plates. And I like leaving some gap here between storages in case you need to route something in between. So just in case. So I'll do that right there, and then that hooks up our steel. This would hook up our slag, and then exhaust I'll just leave as is in case I want to incorporate all of these into a exhaust scrubbing system later. So that gets that hooked up. Now we can do the same thing on this side for coal. So I need to pull from the far storage slot. And we'll do that, and that, and then finish it off with water. So just like that. So that gets everything there hooked up. One thing to consider is if you are using storages, they do have a throughput limit. So in the case of iron, the most we can get through is 900 for these small storages. Same with the water. So we can only ever get 1 belt of throughput through here, even though there is multiple connections. And then 900 for the slag and for the steel out. So we won't need to worry about that, but where it could come into being an issue is if you go to add a 3rd belt for iron. This storage box here would not work for you. You'd need to upgrade to the larger ones, where you get a throughput limit of 3600, or I think it is 8 belts. Yeah, so you can get 8 belts through instead of 2 by going to the larger storage boxes. Something specific to this game. But that gets the starting module, and then we have our expansion module, is how I describe this. And then now we can add in our 4 sets of furnaces. And just to make it look nice, we will rotate it. And we'll just go right over here to the edge. Place that down. Now we'll build it so we can see everything. And because we are in sandbox mode, we can take advantage of the creative tools like the sources and sinks. And we can hook up all of our sources. You could also do always keep full, always keep empty here on the storages themselves. But I like being able to see the input and output numbers. It helps with being able to calculate and make sure everything is running correctly. As well as when I do make blueprints for other people, or for my members on YouTube, I can easily put in here. So if I look at my refinery blueprint, I can put in what all the inputs and outputs are here, so you have a rough idea of what everything is needed, or what you need to run everything. So let's do iron. Then we have coal, our limestone, our scrap, iron scrap, and this one I will actually pause so it doesn't start filling. And then we move on to our fluid source with water, and then we have our sinks. So I'd like to put a label on it. You don't need to, it will just destroy everything, but just so I can see what it is when I click on it. And I'm copying down those numbers for the blueprint. And then same on our unit. So this would be for steel. There we go. And now we can unpause everything. And at 12 times game speed, should be pretty quick on getting everything running. So we can see our copper ore crushed is coming out here on the belts. Going into our blast furnaces, we can look at the productivity of everything and see how it's doing, if there's any bottlenecks, any issues. It looks like these are all running at 100% with full green bars. Nice thing with Captain of Industry, it breaks all that stuff down for you so you can see at a glance. With Satisfactory, you might need to sit there and kind of watch the machines, see how they run, especially if you're using like manifold designs for your belts and conveyors, to just make sure everything fills up and then you're actually getting the production you think you are. So it looks like everything is running here. Yep, we're all green. That means we're green over here. All green over here on the actual production side. So that's our first module. So we know our first module is working as intended. We can look down at our ending module here at the end and take a look. So we are 100% there. We are getting our full 100% of steel down on the end. We can see those smokestacks engaging, venting all that exhaust out. You could also combine these exhaust because we are only getting that 288 or so exhaust. What was it? 72 times 4. Yeah, so 288. You could combine this all down into just one smokestack. That would save you a little bit of, I think, concrete. Let me see. Yeah, a little bit of construction parts and concrete. So up to you. Personal preference again. But it looks like everything is running correctly. We can see, if we look at our unit sink, so we are producing 384. And when I make blueprints for my members, I do keep an eye on these and let it run for a while in game time. That way I can see and make sure it is consistently putting out the numbers that I write down for you. But we can see we're using 768 iron every 60 seconds, 240 coal, 96 limestone, and 0 iron scrap because it is paused at the moment. And then 192 water, 288 slag, and then our 384 steel out. All off of these two, just these 4 blueprints all put together. Now let's look at the iron scrap. So we know this works, but if we look at our iron scrap recipe, we can see that our iron ore use is stopping as we are using the iron scrap. And to demonstrate this working with just a little bit of iron scrap coming in as you are producing your steel, we can see here that everything's going into this belt, into our balancer here. And one thing that we could do to help this process, instead of pushing iron scrap all the way down to the end of our build, we can incorporate the balancers here with the priority output. And then it will prioritize all of that output to one furnace instead. That way you can get a rough idea on how much iron scrap you're burning through and being able to use all of that iron scrap. And then as that gets filled and we no longer need that iron scrap here, so we should see a little bit of iron scrap coming out because we only need 192, so we should see about 8 iron scrap continue on the belt once this backs up, which it might take a little bit of time to back up because there is a storage here in the lifts. So just like your manifold designs on Satisfactory, it takes a little bit of time for everything to back up before you'll see that. So to speed that process up, we'll just upgrade to the next tier. And now we'll see we have some scrap coming out. And then if we had done this in our original blueprint, and there we go. Go like that. Copy that. Unpause all of this. Now it will force everything into our next set of furnaces, which means that we could potentially expand out the furnace array because we're not using as much iron ore anymore since we have all that scrap coming in. But that pretty much covers it for just like the basic kind of design philosophy I use when it comes to putting something like this together. And this is just the production design. So I'm not talking about like any of the layout design when it comes to your island in Captain of Industry, or your factory in Factorio, or what you're working with in Satisfactory or Dyson Sphere. All of your layout stuff is going to be very specific to your playthrough and what you're working on and what constraints you're working around. So that's a lot more detail or more advanced stuff that you have to start taking into consideration. So I'll re-emphasize again, the main goal is to get something that works for you, and that if you can get it to run 100%, that way you are being most efficient with your workers in Captain of Industry, or your material usage. You're not putting down buildings that you don't need. You're not wasting power on buildings that you don't need. Stuff like that when it comes to like Factorio and Satisfactory or Dyson Sphere. So you're trying to be more efficient with your items, and then Over time, you can develop this process and refine your blueprints so they are more efficient, more compact, do what you want them to do, and just kind of get you started on the process. That way you can look at a recipe and go from there. So for example, if we were looking at uranium, so we'll do some uranium processing here. Uranium rods. So uranium rods, it'd be kind of that same idea that I went over with at the beginning, even on a more complex recipe like this. So it doesn't look complex here at first. We need enriched uranium. So we'd click on that. There's two different ways of making it. In this case, yeah, you could do this where you put them all in one building, but just from experience, I know that these are going to be two separate processes because you get two different outputs. So one, you get enriched uranium. Actually, you have two different inputs is how I should say that. So you could hook these together, but then you could run into issues where your reprocessed uranium backs up, and your reprocessed uranium comes from your nuclear reprocessing plant, and then you could have spent fuel backing up, which your spent fuel can only be stored in a, let's see, a radioactive waste storage, and you have a limited supply of what can be stored here. And if you go above that, your belts will back up, and as your belts fill up with your nuclear waste, what will happen is you'll have radiation exposure and you'll start losing people because your health is too low. In this case, because we're in sandbox, everything's ignored up here on the top. But here we can see that we are generating 23.4 air pollution just from these 16 furnaces running. And radiation is a lot worse. Here we are generating 2 radiation level. So it's not too bad compared to like fission products that are 6. But those are one of those considerations that you have to take or account for. And then, so that gets us all the way back to our enriched uranium. Then we need to look at yellow cake. Yellow cake, let's get rid of this. Yellow cake, we would need to make uranium ore powder. Uranium ore powder comes from uranium ore being crushed. Uranium ore would be like the final process then, just like our other crusher was. And then here we would need to look at our secondary products. So we would have our acid, we get our yellow cake, then we have a toxic slurry to worry about. So toxic slurry, we would need to use our waste water treatment. Wastewater treatment, we need to make our filter media. There's 2 different recipes for filter media. So depending on what you want to use as a material is where that would come into play. Then you need brine. Brine is one of those things where you maybe you might have it as a byproduct from another process that you want to use here, or you can just make it here on site using salt and water. So that's something to consider. Then we have a water output and then a slag output. And that is just for this one process here. And then, so that's that. That's the yellow cake that we need. That gets us all the way up to uranium rods. But now we need to look at the math. So now we need 8 uranium enriched. This only produces 0.5. So we need, so that's 1, 2, 4, 8. So that is 8 uranium with 4% to run this one machine. Then we also have steel that we need to bring in. Here on this side, if we get rid of the yellow cake recipe, We need 2 reprocessed uranium, and this is where you need to start considering what your recipe is going to be making. So in this case, a nuclear reactor 2 running full out is going to use 2 uranium rods, which is going to generate 2 spent fuel, which means we can run 4 reactors at max to run off of this one machine here. That's going to make 8 spent fuel. Spent fuel goes into that reprocessing plant, so here, and that will take 8 spent fuel, so 4 reactors to 1 reprocessing plant. Then you need some more of that acid from over here used in this process. Then you need to take some molten glass, depending on how you are going to make that molten glass. In this case, some glass mix, or you could use your broken glass that you get as a recycle. I think that's what most people do, is broken glass, but then you still have to account for the blast furnace here. In this case, the lowest level, because we don't need that much. But for 1 nuclear reprocessing plant, you get 6 reprocessed uranium 1%. That will be enough to run 3 of these. So technically, you could get rid of 3 of these over here, which would cut down on your enriched uranium that you need, as well as yellow cake. Speaking of yellow cake, we need 3 for each one of these. There's 16 of these here. That means we need 8 of these settling tanks. So 4, 8, all the acid that we need. So 8 times 12, that's 96 acid. 1 mixer makes 72 acid, so we need 2 mixers to run all of this settling tanks. That's going to be 36 uranium ore powder. We make 72 per crusher, so we need 4 crushers. All of the toxic slurry, we have 8 times 36 of it, so we're making 288 toxic slurry. That means we need 3 of these guys doing the waste treatment. So we have 3 of those. The brine is enough because we can make 96 brine off of just 1 mixer. So brine's covered. And the filter media, we only need 18 and we make 72 out of a mixer too. So we would only need 1 of these, 1 of those. We'll do something like that so we get an idea of what this layout is starting to look like. And then we also have a byproduct of plutonium. Plutonium we will eventually use to make blanket fuel and core fuel, but you can't do anything with that once you hit nuclear reactor until you have your space program up. So the only thing you can really do with it is you can convert it into MOX rods. So 1 plutonium will make 2 MOX rods. MOX rods you use inside of your reactor. So you can run another reactor at full output, generating spent MOX. And spent MOX is something that you can't do anything with until you get into fast breeding reactors, which means you need to store your spent MOX. You need to also consider your fission products that you get from this process. So you need to store your fission products. You'll probably want to store your plutonium as well. So you'll need 1 of these, and then you'll probably want to have some storage for your spent fuel. So you're going to have 1 of these as well. And so you can see how quickly one of these recipes that look relatively easy, how complex and how many different inputs and outputs all go into designing just a nuclear reactor or something like that. And the same goes for other games like Factorio. When you start getting into your more complex production chains, trying to think, Coverax enrichment's not too complicated once you kind of understand it. Satisfactory would be like your end game elevator parts that you need to finish your elevator. That's where you'll run into a lot of these more complex recipes where you need production from all over your base to run this stuff, compared to, you know, setting up a smelter array, which is relatively simple. But hopefully this video helps you with understanding kind of the basics and the thought process that I use, and like the decision making I use when it comes to putting a blueprint together and helping you kind of get past that bottleneck or that hurdle. That way you can start designing your own blueprints to use for your factory, and kind of just develop this and get an understanding, and let you start progressing through the game without getting stuck on trying to figure out all of the recipes when you look at a new research unlock and go, okay, I need to make microchips or electronic 3s, but to do that I need microchips, and you get to these complicated recipes, or even your space program parts, stuff in the later portion of the game. Same with Factorio, when you're getting into your rocket research, your space science, starting to explore, go into other planets if you have the DLC, and then same in Satisfactory with those endgame products, and Dyson Sphere as well, when you start getting into the logistical hurdles of interstellar logistics. But hopefully this helped you. I hope you enjoyed the video, and I will end it here for this part 1. I will have a part 2 where I will actually build the blueprint I am going to put together for titanium and aluminum smelting. That will be in my next episode of my Captain of Industry Let's Play. So thank you so much for hanging out and watching. I hope you enjoyed the video, and I'll see you guys in the next one.